Good morning, ladies and gentlemen. Welcome to PMC online pre-training session. So we're going to carry on with the mechanical equipment presentation as we started with the heat exchanger, level 1. We're going to touch base on the reboilers and condensers. So Olga will take us through the presentation today. Hopefully you will enjoy it, and we will pause as usual in every single slide to give you the chance to ask a question or to clarify things that wasn't easy to comprehend. So I'm gonna hand over now to Olga. Thanks, Olga.
Hi, hello, good morning, all of you. Thank you for this session, for the Reboilers and Condensers session. In today's presentation, we are gonna start also with a safety moment. It's a safety moment regarding also a heat exchanger. So it's regarding a gas plant explosion located in Australia at Longford near Sale in Victoria. Is an ESO plant that processes crude oil and raw gas from vast state offshore oil fields. The site comprises 1 unit for the crude stabilization plant and 3 gas plants. The GP1 is refrigerated by lean oil absorption, and the GP2 and 3 are cryogenic separation plants. So what happened in the accident? On Friday 25 September of 1998, an explosion and fire that burned for more than 2 days occurred at the ESO Longford facility in South Gippsland in Victoria. As a result of that explosion and fire, 2 people were dead and 8 were seriously injured. Also, all natural gas supply from the Longford facilities ceased, causing major disruption to Melbourne, the industry and retail consumers. So why happened this gas plant explosion? The detonizer reboiler, the one you see here, the shell temperature fell from 100 degrees to minus 48 degrees due to an accumulation of plant malfunctions of the plant. So ice was formed on uninsulated surfaces of the reboiler. Then the pump restarted and the warm lean oil flow resumed to GP 905, the one that exploded. So the reboiler steel became brittle, and thermal stress generated by radial expansion of the tube sheet created stress that resulted in brittle fracture. So the consequences of this explosion was that a vapor cloud containing flammable gas emitted, resulting in an intense jet fire beneath elevated pipe rack junction. They were unable to isolate leak, and flame impingement caused 3 more leaks. An entire plant inventory was lost, and fire burned for more than 2 days. And 2 people were dead and 8 were injured. So the Royal Commission did a study of this gas explosion, and they found the following. they found that this explosion had occurred because inadequate personnel training and lack of operating procedures. They also had in the plant excessive alarm and warning systems that caused that workers were used to these alarms, and then they become desensitized to possible hazardous occurrences. There were also poor communication between shifts, meant some previous malfunctions so were not communicated to the following shift. The company did not perform hazard analysis, safety analysis of the heat exchange system, which would have highlighted the risk of tank rupture caused by sudden temperature change. And also finally, the company's safety culture was more oriented towards preventing lost time due to accident injuries rather than workers' protection and health. So after these findings, the following recommendations were done after these findings and conclusions to the following recipients. All major hazard facility sites shall have the safety case extended to them by legislation. Also, a design review of critical facilities areas to minimize risk of serious accident, including an isolation philosophy. Also, the periodical review of operating standards and practices and the training of employees in identifiable hazards and the procedures to deal with them. And finally, a safety and risk assessment and the responses required to minimize likelihood of accident, including fire risks analysis and emergency response. So,
sorry, Olga, can you go back to the previous slide? I want to explain, you know, some stuff. No, just stay. No, sorry. Yeah, this one, yeah. So
okay.
I just want to explain, you know, this slide again, just to maybe in Arabic a bit. Yeah. Okay, thanks, Olga.
Okay, you're welcome.
Thanks. شباب شوف الفكرة من السيفتي كلش مهمة لأنه دائما بها مسجز تفيدكم بالحياة العملية إن شاء الله من تشتغلون بالمصفى. فيعني مثلا الحادث اللي شفناه بالغاس بلانت اكسبلوجن، يعني ذني النقاط اللي لقوا بها التقصير اللي صار من بالبلانت. فأول نقطة اللي هي واضحة أنه التريننج بيرسونال تريننج كان مو كافي، وبنفس الوقت يعني ما عندهم كان الاوبريتنج بروسيجر، بحيث انت كل ايفنت عندك او كل حدث يصير لازم انت تعرف الاكشن مالتك شنو هي. يعني مثلا صار عندك باور تريب شنو تسوي، مثلا صار عندك حريق بمنطقه او شلون تعزل، فهذه تكون انت من متدرب عليها تعرف الاكشن الصحيح. فكان عندهم قله خبره في الاوبريتنج بروسيجر. النقطه الثانيه هذه كلش مهمه، ما اعرف اذا قسم منكم جزء ما كانت واضحه له، الاكسسيف الارم اند وورنينج. بسبب انت تقعد بوحده وبعدين تصير كلش متعود على الالارمات، فشو تسوي لها؟ دائما تدوس اكنولج يعني يجنورت. فبالبلانت هذا الحادثه اللي صارت كان كثير الارمز تصير بغرفه السيطره. فشنو الكلمه هنا كاتبها؟ بيكم دي سنسيتايزد، يعني يقوم يصير يعني غير متحسس لها، ما يروح يسوي اكشن يشوف هذا الالارم ليش او يحلله شنو هو الحل لهذا الالارم. فلكثرتهن فقاموا يصير عندهم تآلف وياها، فصار مثل الاجنور عدد الالارمات اللي يصير عندهم بالوحده. فبالنتيجه من انت تقوم تظل اكنولج، طبعا شايفيها احنا هذه بالتشغيل، تتعود عليه، تقول لي اوكي هذا بي مشكله، اوكي اكنولج، بس ما راح تاثر. بس لازم فعلا انه تاخذ اكشن حقيقي حتى الالارم تحل مشكلته، يعني مو بس يعني يو وماكو اي حل. فواحده منهم هذه انه هم كثره الالارمات، هم اجنور المشكله. الكوميونيكيشن كان بها اشكال بين الشيفتس، وهذه مهمه. انت من تسلم الشيفت مالتك للمهندس اللي راح يستلم منك، لازم كوميونيكيشن واضحه بالضبط شنو الاشكالات اللي صارت خلال الشيفت. هاي مهمه. اضافه انه الكومباني did not perform hazard analysis. هذه مهمه. يعني انت من عندك تغييرات بالمصنع او تغير بالاوبريتنج كونديشن، لازم اكو عندك تيم يسوي هازوب. الهازوب اللي هو هازارد اوبريتنج اناليسيس او ريفيو. فلازم اي تغييرات تصير عندك لازم انت تسوي لها تحليل، شنو هو تاثيراتها، شنو البوتنشال انه تسبب اثار على المعدات او الظروف التشغيليه. وممكن تحتاج جزء الارم تضيف، ممكن تحتاج تضيف فالف تعزل به الى اخره. فهذه مهمه. سيفتي كلتشر، كومباني سيفتي كلتشر، هاي شنو معناها؟ احنا للاسف طبعا بالعراق هذه مو كلش هوايه موجوده عندنا السيفتي يعني كلتشر. القصد بها انه الناس مثلا تكون حذره بالتشغيل، تكون مثلا لابس البي بي اي. مثلا احنا شايف انا بالدوره مثلا الناس تغسل البدله مالتهم ويا الكيروسين. فهي هذه مثلا ما عندنا احنا سيفتي كلتشر. فهي هاي الفكره. السيفتي كلتشر كلش مهمه، انه الكل تطبق القانون السلامه بحذافيره يعني، وما يصير به تهاون. هاي النقطه الخامسه مهمه يعني. فبس ردت يعني يصير تذكير بهاي النقاط، لانه هذا راح تعيشون وياها on daily basis الاشياء يعني. اوكي شكرا. Thanks Olga. Sorry, you can carry on now. I just
Okay,
want to
thank you.
brief this slide. I think is very important because it's how they're going to deal with the practical life on daily basis with all those items, I guess.
Yes, actually, when I read about this accident, what I saw is that the findings that the Royal Commission found was findings very, very, very important. And these findings are usually the cause of many, many, many accidents in many industries. And I found these 5 findings are very important to control and to take in our minds to avoid this kind of accidents, because actually this accident was the conclusion of several other malfunctions of the plant. So
yeah, true. Yeah.
Mm-hmm.
Thanks.
You're welcome. Okay, so this presentation will talk about reboilers and condensers. And in today's session, we are gonna talk about reboilers, and we will do the condensers next week in our second part of this presentation. We are gonna start with the boiling phenomenon, and then we will talk about, we will do an introduction to reboilers. Then we will talk about all different reboilers, and finally, we will explain briefly how to select the correct reboiler to our system. So first of all, what is boiling? Boiling is the vaporization of a liquid which occurs when a liquid is heated to its boiling point. So then, the boiling point of a substance is the temperature at which the vapor pressure of a liquid is equal to the pressure surrounding to the liquid, and the liquid changes into vapor. When designing reboilers, we always check how boiling phenomenon is working along our heat exchanger, and we use graphics to see how the boiling phenomenon is working. In this first graph, it is represented the temperature of the fluid along the length of a shell and tube heat exchanger. On the shell side of the exchanger, we have a medium pressure steam around 8 bar that we use to vaporize the process fluid located on the tube side. We can see here in blue. So we can see that the steam enters in the exchanger a bit superheated. It is entering, I'm gonna do some zoom. It is entering slightly higher than 175 degrees. So after losing, this is the inlet. After losing some pressure in the exchanger, it achieves the saturated temperature at around 170. So then here we have the MP steam condensing. In blue, we have the process fluid that we want to vaporize. The inlet temperature in the exchanger is 145, and it exits the exchanger at 146. In this second graph, it is represented the vapor is the same exchanger actually, but we have represented the vapor fraction of the fluids along the tube length of the exchanger. We can see how the medium pressure steam is totally condensed from totally vapor to totally liquid. And how the process fluid, the process liquid that we want to vaporize, and it is inside the tubes, it is going from totally liquid and it vaporizes along the tube side until 5% of vaporization. So there are different types of boiling or heat exchanger, heat transfer regions that can occur in a reboiler, depending on the fluid properties like density and viscosity, depending on the velocity of the fluid, and also the design of a heat exchanger. If it is designed vertical or horizontal, or with one type of baffles or another. So depending all these factors, there are different types of boiling that can occur in our boiler. Here this is a sketch of all different boiling we can have. So we can differentiate the following types of boiling. The nucleate boiling, where we have some small bubbles of vapor that form at discrete points. This is the most stable regime, and this is the regime we want to have when designing a reboiler. We have also the critical heat flux boiling and the film boiling. For the first one, the boiling surface is heated above a certain critical temperature and a film of vapor forms on the surface. It appears when the heat flux increases to a maximum value. And also the film boiling is a thin layer of vapor formed on the surface, which decreases the heat transfer. And finally, we have the transition boiling, is an intermediate, unstable form boiling with elements of nucleate and film boiling. So we will try always when designing a heat exchangers, a reboiler to be in this part because it's the most stable boiling phenomenon. We can be sure that the results we are obtaining in with our program, with our design program, will be what will happen in the reality.
Sorry, Olga, can you go
Yes.
back to this slide here? Let's check if we have some questions. شباب أحد عنده سؤال أو استفسار عن التعريف مال البولينج وهاي الريجنز مالته المختلفة؟ واضحة؟ Okay. Olga, I just want to ask about this slide and the different regions of the boiling. So obviously for design purposes, we want the boiling to be in the first region, which is called the nucleate boiling, yeah?
Yes.
Yeah, so what happens if we get the fluid inside the tubes, for example, in the critical or film boiling pattern? So is it undesirable or it's okay? It's still within operating, but it's better to work towards the nucleate boiling.
It is less likely for us because then we need to consider in our design that, for example, when we have a nucleate boiling reboiler, we are very sure that what we have in our program, in our design program, will be what will happen in the reality. But if we are designing in our program, it is written that we have slack flow, for example.
Yeah.
Then we have to avoid having this kind of flow. So then we do modifications in our design, and then we can increase or decrease the piping, the outlet piping, to reduce, in this case, to reduce the area and to reduce the vapor formation. We also can, it's like play, it's like we can play with our design to achieve a good nuclear and a good regime.
Okay, but what's the criteria or the indication that you are in this region and not in the annular flow, or you are not in the filming boiling? Is what's the parameter you have?
It is in HRI, as I said in the last training. We are using HRI or also with HISIS simulation program.
Okay.
It is already is a result that the simulation programs give us.
All right. Yeah. Okay. Thank you so much, Olga.
You're welcome. Okay. So now let's gonna do a quick introduction to reboilers. So a reboiler is a heat exchanger used to provide heat to the bottom of the distillation columns. In the image, we can see a kettle reboiler that on the shell side receives the fluid from the bottom of the column, and the outlet returns to the column. On the tube side, the inlet, it is in this case steam coming from a heater, and it returns again to the heater. So then the liquid is heated from the bottom of the distillation column to generate vapors that are returned to a column for driving distillation separation. All vapors that drive the separation come from a reboiler in the typical column classical distillation. The reboilers receive a stream of liquid from the bottom of the column and may completely or partially vaporize that stream that goes after again to the column. Reboilers are classified into different forms according to the type of circulation and their orientation. We classify them in natural circulation and forced circulation. Let's gonna start with the natural circulation. In this sketch, we can see how the liquid fluids come from the bottom of the column into the reboiler, where it vaporizes. Here it starts to vaporize, and it returns to the column. The main characteristics of the natural circulation reboiler are that the return piping to the column is sized for two-phase flow. They operate on thermodynamic principles rather than gravity. The thermosiphon operation is simple, but they are often difficult to design for a wide operating range. And finally, proper elevation is critical because, well, here we need to ensure a good hydrostatic pressure difference that allows flow circulation, since we said here that operation is on thermodynamic principles. So these are the main characteristics for the natural circulation. We said also that the other classification were have forced circulation. So here in the sketch, we can see that the fluid coming from the bottom column is pumped into the reboiler, where it vaporizes and returns to the column. The main characteristics of forced circulation are that they are usually designed to operate full liquid. So then flashing occurs as the liquid crosses the control valve, and valve should be located close to the column shell. They offer greater operational flexibility than thermosiphon, and they have smaller footprint than kettle reboilers. Kettle reboilers we will see later in this presentation which type of reboiler is.
What do you mean, just for people who doesn't know what footprint means?
Footprint is the size we need to have free in our plant, yeah, to place our reboiler.
Okay, so it's the area around the equipment.
The area, yes.
We've got a question.
Ahmed, there is a question.
Ahmed. Yeah, I know. Hello, Ustad Adi. Just ask how the material transfer between two equipments. That's what we are explaining, Mr. Muhammad.
Maybe talking about natural circulation, not forced.
لا هو هسه احنا بسمح لي هسه احنا ايش بدنا نحكي الانواع الريبويلرز، فواحد منهم ناتشرال يعني هو السائل يفلو يروح للريبويلر وبسبب الحراره يندفع مره ثانيه.
هو يريد الآلية ابو يوسف.
مساء الخير استاذ.
يريد الآلية ابو يوسف.
اوكي هلا استاذ. هلا عين
استاذ، انا سالت عن الآلية يعني العفو. هسه احنا عندنا تو ماتيريال بالليكويد، بحاله الليكويد بس سالت انه كيفيه الانتقال هي تحدد عن...
استاذ احنا بدنا نحكي هو كيفيه الانتقال. السلايد اللي قبل هاي قلنا ناتشرال، يعني انت بسبب ارتفاع العمود السائل ينتقل السائل من اسفل البرج يروح للريبويلر. الريبويلر ايش بيه؟ اكو مصدر مال حراره تبخر وترجع البخار والسائل بسبب ارتفاع الحراره يترجع مره ثانيه للكولوم. هاي الطريقه الثانيه هسه تقول لك بامب اللي هي فورس. هن ذن الطرق الاليات النقل. ده تفهم قصدي؟
تمام استاذ. واني كنت اسال انه شلون ناتشرال بدون بامب، بس هسه من طرقت لل يعني
لا
اكو
الناتشرال. Sorry, Olga, can you go back to the previous slide, please? Just this question about the transfer of the liquid. Thanks. So انت شو تسوي هسه اذا تشوف وياي على اليمين اللاين ينزل من الكولوم وين يروح للريبويلر. تسمعني استاذ؟
نعم.
شلون يروح؟ السؤال شلون يروح؟ بسبب اختلاف عمود السائل. الكولوم اعلى من الريبويلر. تفهم قصدي؟
نعم.
من وصل للريبويلر ايش عندك ذني السهمين، الواحد ان والاوت اللي على ايدك اليمنى اللي هو المصدر الحراره مثل الستيم. ايش راح يسوي؟ راح يوفر حراره، يرفع درجه حراره السائل الجاي من الكولوم بحيث شنو؟ بسبب ارتفاع الحراره يصعد الضغط فيرجع مره ثانيه للكولوم. هاي ايش سميناها؟ سميناها هاي الطريقه استاذ ناتشرال سيركيليشن المكتوب.
نعم استاذ. هاي ناتشرال بدون بامب.
اي واضحه؟
اوكي استاذ.
سؤالك يعني على هاي لو هو هسه احنا بدنا نحكي طرق. هو هسه يعني السكشن هذا بدك تحكي به هو طرق النقل السائل. فواحده مضخه هسه الثانيه فورست، يعني انت بقوه خارجيه تجبر السائل يندفع من البرج وين يروح للريبويلر، او ما تريد بمضخه تريد بالناتشرال. هاي طريقه الناتشرال. فرق اختلاف عمود السائل. تفضل استاذ مصطفى.
شكرا جزيلا.
اهلا وسهلا.
السلام عليكم.
السلام ورحمه الله وبركاته.
استاذ بس توضيح للنقطه الثانيه operating on thermodynamic principles rather than gravity.
operating on thermodynamic. اي فرق يعني الحاله الفيزيائيه. يعني انت ايش راح تستغل طريقه العمل شلون thermodynamic principle rather than gravity. يعني انت شو تسوي؟ انه مو قلنا نجيب مصدر مال حراره، فايش راح تغير الحاله الفيزيائيه بسبب الثرمودايناميك اللي هو يعني الهيت ترانسفير، الهيت اوف فابورايزيشن. ها كل هالعوامل راح تدخل بيها تغير الحاله من سائله الى تو فيس، ترجعها للكولوم. فما تستعمل قوه ثانيه مثل المضخه. يعني هذا القصد. Olga, the question about what does it mean using the thermodynamic principle. So I explained a bit, but if you can add for this point, please.
Okay, yes. It means that we need to have these. It is working with the hydrostatic pressure defense, so we need to have a liquid static head between the column and the reboiler that allows our fluid circulates. So it is not working as we have in our mind a gravity flow, but it is working with the hydrostatic pressure difference between the column and the reboiler.
Yeah.
So in this case, for example, we have the column full of liquid from the column here till here.
Yes.
So we have here a liquid static head that allows our fluid circulates.
Yeah. Well, in terms of thermodynamic, is basically in case you change the status of the liquid into two-phase and you have a vapor phase, so you're utilizing the heat of vaporization, you're utilizing, you know, the heat transfer to force the liquid and the vapor to go back to the column. So that's why you don't use pump here.
Exactly.
Yeah.
And this is why here having a good elevation of the
Yes.
of the exchanger is very critical. To
Yeah.
have this liquid static head, we need this distance. When I say liquid static head, it's just to have a distance here full of liquid.
Yes. Yes. Otherwise, you miss the circulation. Yeah.
Exactly.
Yeah.
So here, since we have the pump,
Yeah.
the elevation is less critical because we are forcing our fluid to circulate.
Yes. Yeah. Okay, let me go back. واضح استاذ على السؤال اللي سالته؟
ممنون.
ماشي. استاذ عدي عندك شيء العفو انت تقوله؟
لا سلامتك ابو يوسف. سلام.
واضح واضح.
بس الارتفاعات، فرق الارتفاعات خصوصا بالناتشرال.
اي
فرق الارتفاعات هو جاست حتى نضمن الاميرشن مال الويل، يعني الانابيب كلها انغمرت بالسائل مالتنا. يعني
بالضبط. هو شنو يعني انت
لذلك هي حاطه علامه للليفل يعني بين الريبويلر وبين فلهذا يفضل دائما مو العمودي بالناتشرال، يفضل الكتل الافقي.
هسه احنا لن نضرب تفاصيل، بس
يعني
الفكره المبدا الاساسي انه انت اقصد شو يصير اذا صار اي اختلال عندك بعمود السائل، ما راح يصير عندك سيركيليشن.
واذا ما الفكره القديمه
واذا ما صار عندك سيركيليشن راح يتاثر الهيت
ترانسفير، يوقف الهيت ترانسفير بعد يوقف.
اي بالنتيجه
هسه هي اكو عندهم مشكله هسه بالبرابان، خابروني من ورا هاي السالفه. هسه انتبهت لها. احنا دائما نقصد الكثافه، يعني نقصد الجرافيتي. نقول احنا السائل ثقيل بارد فينزل للاسفل، من راح يتبخر راح تصير البخار اخف، فراح يرجع يدخل لها بسبب الكثافه. يعني دائما احنا نزيد
بس مو هو قد
يصير السيركليشن
يرجع تو فيس، مو شرط
يرجع. نعم تو فيس، بس بالبدايه ثقيل بعدين يصير خفيف من
صحيح.
نعم. يصير السيركليشن ناتشرال. بالضبط.
شكرا. Okay, Olga, sorry, you can proceed.
Okay, thank you. We are gonna talk more about all these phenomena during the presentation, so.
Good, yeah, thanks.
Okay. So here in this sketch, we have classified all different type of reboilers in these two types of reboilers regarding the circulation, natural circulation and forced circulation. So the reboilers, the different type of reboilers we can find in the natural circulation are the kettle reboiler, an internal reboiler inside a column, also called bundle in column reboiler, a vertical and horizontal thermosiphon, which we will see the natural circulation and also the ones through circulation, these two types in vertical or horizontal. And for the forced circulation, we can have the equipment placed vertical or horizontal. In this sketch is just a horizontal sketch. So now in the following slides, we are going to explain each reboiler we have in the natural and forced circulation in this classification.
Okay, Olga, but the question is here for me as outsider, for example, how I decide to go whether forced or I go to natural. So to begin with.
This is the end of the presentation.
Oh, okay. No,
But
I
yeah.
will wait. I will wait. I won't burn. I won't burn the card. So
We will explain. First of all, I want to.
the main purpose is the amount, Ahmed.
لا هسه أنا
If you have a big amount of liquid, you need to maybe stabilizing or something. It's
yeah,
you must use a faucet. Yes, we will wait. We will wait all good. Yeah.
Okay.
Okay.
If you have a small amount, you could use a natural.
Well, yeah, this is actually there are many factors. First of all, I want to explain all different exchangers and also...
No, carry on. If you
Okay.
have the answer in the end or at some point, no problem.
Okay, good.
Carry on.
So let's gonna start with the kettle reboiler. Kettle reboilers, also called submerged bundle reboiler, are commonly applied when a wide range of process operations for high turn-down capability, large exchange surface, or high vapor quality is required. Installations include column bottom reboilers, side reboilers, or vaporizers. And they are often used as vaporizers, as a separate vapor liquid disengagement vessel is not needed because the kettle has an area above the tube bundle which works as a vessel and separates the liquid and the vapor. They are suitable for vacuum operation and for high rates of vaporization up to 100% of the feed. So,
I'm sorry, but what do you mean by high turn down capability?
High turn down capability, the function, the operation of the kettle is very stable even when we have a high turn down capability. It means that,
basically if you operate, say, for example, 100 tons of reboiled fluid back to the column, the turn down can be 30% of that. So you can, they give you the same quality for 30 tons.
Exactly. With the thermosiphon, it is not very well controlled as for the kettles.
Yeah, so you can work with a various capacity and also with the big flexibility in your operation. So if you go down from 100 to 30, still you get the same quality. You don't mess the heat input to the column.
Yes.
واضح أستاذ مصطفى؟ أتصور أستاذ مصطفى.
واضح أستاذ أحمد. Thank you.
You're welcome. I wanted to explain also what we have in sketch. We are taking the liquid from the bottom of the distillation columns. We fill the shell with this liquid, and here on the top of the bundle we start to vaporize. And here we have this area free of tubes, free of liquid, what we called the disengagement area. It was here written. This is the disengagement area, and this is what we can approximate like having a vessel that separates the liquid with the vapor. So then what we have here is just vapor, and no liquid goes to the column. So kettle reboilers consist of a tube bundle supported by plates. These are the plates. The structure of tubes can be either straight tubes or U-tubes, as we see in this sketch. The tube bundle is placed inside a large, specifically designed horizontal shell known as K shell. And the most common thema types are for fixed tube sheet exchangers, we have the AKM, or the BKM. This one is an AKM. When I say A is because we can open this tube part to have better access to the tubes, to the cleaning of the inside of the tubes. And for the removable bundle, we have the AKS, AKT, and BEU. Sorry, we have here, yeah, the BK, AKU. This is a U with U tubes. Usually a kettle type is provided with a wear. The wear is this liquid level plate inside the shell to control the level of the liquid in this part. The vertical length of the wear dictates what quantity of liquid will be retained in the shell. It is important because the tube bundle must compulsorily be immersed inside this quantity of liquid at all times during the runtime of the process. It means that we are filling with our liquid the shell, we are filling the shell, and this liquid will arrive till the top of this plate. And then if we continue putting more fluid, we will have some liquid that goes to this part. It's in this part where we will control the amount of liquid. So how a kettle reboiler works? The liquid to be vaporized flows through the shell side due to the effect of gravity maintaining an adequate head with the column. The processed liquid covers the tube bundle entirely, and this liquid is commonly called bottoms in the distillation process. The steam, in this picture is oil, but it can be also steam, flows through the tubes. Pass partitions are provided to get highly effective heat transfer relative to single pass. So the steam flows into the tubes to heat and to vaporize the liquid on the shell.
Well, what's the return to the column? Is it a mix of the liquid and the vapor, or just the vapor back, purely vapor back to the column?
This one?
Yeah.
Here we only have vapor.
Yeah, okay.
It's just it's just vapor because we have this disengagement area where vapor gets separated from liquid.
Okay.
So it's just this last paragraph. Above the tube bundle, there is the vapor disengagement area where the liquid is separated from vapor, and thanks to that, it can reach rates of vaporization up to 100%. And thanks to this disengagement area, it is not needed having a vessel after the exchanger to separate the vapor from the liquid. This sketch is the cross section of kettle. Is like if we take a look to our kettle from the side, from this part, we have the tube bundle, and then this part is the shell liquid where all the shell is full of liquid. And in this part, this is the disengagement area, is the area where vapor is separated from liquid. So the main advantages of having a kettle type reboiler is that they are very stable in operation because kettle is relatively insensitive to system hydraulic changes. As a result, it is reliable even at very low vacuum or high near critical pressures. They have good control at turn down. The separation efficiency of the boiler approaches to one theoretical stage in the column. And as drawbacks of kettle type reboiler, we have an oversized Tema K shell that makes the exchanger more expensive than other reboilers, because since we need to have a disengagement area, we need to have a big shell. Low circulation rates make kettles very susceptible to fouling. And finally, we need a big plot area to place our kettle, because since we said we need a big shell. So this is all for kettle reboilers. If you have any question of this type, please just let me know.
Okay, so just let's give chance. شباب أحد عنده سؤال استفسار عن الكاتل تايب؟ تفضل أستاذ مصطفى.
السلام عليكم أستاذ بس السلايد 15.
Olga, sorry, if you go back to previous slide 15.
Yes.
تفضل أستاذ.
أستاذ liquid level plate هاي هنا يعني إذا عبرها المي، يعني إذا عبرها الليكويد هنا مثلا راح ينزل هذا المجرى كأنه ماكو جوا هذا أنبوب لو شنو؟
اي طبعا عندك انبوب انت بايب يطلع منه وانت تسيطر على كميه الليكويد، بس الليكويد وين راح تستلمه من هذا الجهه يعني ورا الوير هذا اللي هو مثل البفل هذه او الليكويد ليفل بليت يسميها، تستلم الليكويد السائل يطلع بس من هاي الجهه هاي والتوب فيبر.
زين هذا اللي يعبر الليكويد ليفل بليت وين يروح؟
انت اما يكون راجع مثلا يكون راجع للريبير
او هذا انتاجك ابو يوسف
او برودكت. اي بالضبط برودكت
هو هذا انتاجك، يعني انت ما نقيته يروح للبرج ويطلع انتاج، يرجع للقعر مال البرج ويروح انتاج.
اوكي سلايد 17 ولا
next slide sorry 17 this one yeah okay تفضل.
What you mean by good control at turn down؟
نفس اللي سألتني إياها قبل شوية، هي نفس الفكرة.
يعني هي نفس
الموضوع نفس يعني يعطيك flexibility بالعمل يعني.
اوكي
نفس الفكرة اللي أنت ما أعرف إذا أنت نفسك أتصور نفسك سألتني قبل شوي. نفس الجواب يعني هو أنت يعني معنى turn down إنه أي وحدة أو معدة عندها ظروف تشغيلية كفلو تشتغل 100% أو تشتغل 50%، بس أكو قسم ما يشتغل 50%، أكو قسم معدات تشتغل 60% مينيمم. إذا صارت 50 هي تشتغل مو ما تشتغل، بس ما تعطيك المواصفات اللي أنت تريد. فنفس الشيء فيما يخص الكاتر. شباب أحد عنده سؤال أو استفسار عن الكاتر؟ ماكو أي سؤال؟ Okay, Olga, sorry, you can carry on.
Okay, thank you. So the next natural circulation reboiler is the vertical thermosiphon recirculating. This is a very, very, very common reboiler in industry. The vertical thermosiphon reboiler is a vertically mounted single pass shell and tube heat exchanger with the boiling fluid on the tube side. In the last reboiler, the kettle reboiler, the boiling fluid was located on the shell side. In this case, the boiling fluid is on the tube side. The liquid passes from the bottom of the column into the reboiler with the evaporation taking place inside the tubes. The heating fluid, typically is condensing steam, is placed on the shell side. The two-phase mixture is discharged back to the column, where the liquid settles back to the liquid pool and the vapor passes up the column as shown. So it means we have here liquid, one phase, just liquid. And when it starts here to enter in the tubes, and we have here on the shell, the condensing steam, this liquid start to bubble inside the tubes. So it start to have some vapor phase that we will go to the column mixed with the liquid. So then here we will have vapor and liquid. The vertical thermosiphon reboiler is less susceptible to fouling problems than kettle, and in general, it has a higher heat transfer coefficient than the kettle reboiler. This is because the velocities we can achieve, the fluid velocities we can achieve in a vertical thermosiphon reboiler are higher. And then since the velocities are higher, we have then less depositions of the fluid and is less likely to be fueled than in a kettle. And since we have higher velocities, we will have also higher heat transfer coefficient. As we said here, additional height is required to place the reboiler and to have this liquid pressure static head to allow to move our liquid and our vaporization. The main advantages of vertical thermosiphon recirculating are that the exchanger is cheap, the low plot area requirements, since we have is a vertical exchanger, high circulation can be achieved, leading to high heat transfer coefficients and low fouling. The single pass tube side arrangement facilitates cleaning, and it can be performed without removing the exchanger. It means that here we have just on the tube side, we have just one pass. So then to clean our tube side is easy because we just need to take out this part or this part, and then we can clean the tube side. The process fluid is on the tube side, which is an advantage for corrosive fluids. And as for drawbacks, vaporization rate is maximum 35%. It means that maximum vaporization rate we will have at the inlet of the inlet in our column here. We can have just only 35% of vapor. With kettle, remember we were able to have at the inlet of the column 100% of vapor. With a thermosiphon, only we can ensure that we will have 35%. The column usually has to be raised to the above the boiler, requiring an increased skirt or additional steelwork. It means that to have this natural circulation in our thermosiphon, since we need to have this pressure difference, we usually have to raise the column with having more skirt and additional steelwork. The performance tends to be poor near critical conditions where the liquid and vapor have similar densities. So thus, this gives little force for the recirculation. Third down is limited. It can be unstable in operation with circulation and vapor generation varying. This is when we talk about the kettle, we said that third down was more stable than thermosiphon. And being a single pass, we said that it was easy for cleaning, but as a drawback, being a single pass, it is difficult to allow for differential expansion. So then when large different temperatures are present, we need to have expansion joints or shell bellows, as we said in the heat exchanger last training. And the boiler does not contribute to a full theoretical stage to the separation on the column. The kettle, it contributes with a full theoretical stage, but not the thermosiphon recirculating. Okay, so this is for this is a vertical thermosiphon recirculating. If you have any question of this.
شباب من عنده استفسار سؤال على الثرموسايفون؟ يعني كلها فاهميها؟ Okay, تمام. Okay, Olga, so you can carry on. Don't see any questions. Okay. Olga.